The other type of right triangle you're going to run across is, and then you're going to have to memorize some ratios or some ways of getting around. It is going to be a, this doesn't look great, but it'll work, is going to be a 30, 60, 90 right triangle. There are certain ratios that apply here. I'm going to now show you how we can figure out what they are. But once we figure out what they are, the truth is you really want to make sure that you commit this to memory and practice it enough that you're comfortable with it. So we start with a triangle that is an equilateral triangle. That means this side here is the same as this side, which is the same as this side in terms of the length. And the angles are the same. This is a 60-degree angle, this is a 60-degree angle, and that's a 60-degree angle. Because the three angles of a triangle add up to 180, and if they're all equal, they're all 60. First thing I'm going to do is drop an imaginary line down from here straight down, a perpendicular bisector. Just crazy talk. But all that means is by doing this, I've split this angle that was 60 into two 30s. So we'll use two lines for that. So these are now a 30-degree angle, and this is a 30. I've split, this is 90-degree, perpendicular bisector, and this side, the way we'd mark it in geometry, is equal to this side. So really, if you notice, I've split it into two 30, 60, 90 right triangles. Do you see them? All right? Here's one of them. And it's back to back with the other one. So right away, this should bring up, focus on the blue one right now. This should bring up one of the ratios. It's very simple, and it's the one you really want to latch onto. And that is that this side of that 30, 60, 90, right here, well, remember, this whole side here got cut in half. So this side right here is S over 2. In other words, it is half of the hypotenuse. And if you remember nothing from a 30, 60, 90 else, you must remember this. That the shortest side in the 30, 60, 90, so let me draw a better 30, 60, 90. So if I just draw some 30, 60, 90 here, we'll do it this way. Roughly 30, 60, 90. That the shortest side is always half of the longest side, the hypotenuse. So if the shortest side is 5, the longest side is 10. Or, if the longest side was 15, the short side is 7.5. So the factor there is just 2. So first thing we know is that if I'm going from small to large, I would multiply by 2. If I'm going from the hypotenuse and trying to find the small side, I would divide by 2. This, another saying the same thing in another way, this side is double this one. Okay, so what about this side? Well, now we can use Pythagorean theorem. I'll call this, I'm going to call this L for one of the legs. So L squared, well, we'll do it this way. S squared equals L squared plus half of S squared. Notice how I wrote that. Take a look at it. Does that make sense? Your hypotenuse, yeah, this is your hypotenuse. This is one of the legs, and this is the other one of the legs. And we're solving this for L. So I would have S squared minus S over 2 squared equals L squared. See what I did? I subtracted this from both sides, and that's how it disappeared over here and showed up on the left as a negative. Now I'm going to take a moment, and we're going to clean up this side. I'm going to square this, which means I can square the S and I have to square the 2 as well. So I have S squared minus S squared over 4 equals L squared. Now, you might want to make sure you're sitting down because I'm about to do some fraction stuff and might freak you out. You'll be all right. It's okay. Check your pulse. You'll be all right. Here's the deal. So I want to actually subtract these. This thing has a denominator of 4. So I'm going to do this. I'm going to multiply this top and bottom by 4. In other words, 4s squared over 4 minus s squared over 4 equals L squared. Take a look at it. Notice I could cancel these 4's and I'd have this, wouldn't I? So it's really the same thing, except now the two denominators are the same, and I can easily do this subtraction. I have 4s squareds minus a single s squared. The denominator is going to say is 4. Or another way of looking at it is I have 4/4 of something minus 1/4. So I have 3/4 left over. So I have 3s squared over 4 equals L squared. Okay. Now I'm going to take the square root of both sides. So I have the square root of 3s squared over 4 equals the square root of L squared. Well, that just means that this all boils down to L. In fact, I'm going to write it over here. Over here, well, I can break it up over all of these. I can write that as the square root of 3 times the square root of s squared times over the square root of 4. You're welcome to break up the square root over division and multiplication. Well, I can take the square root of this and this. So I have L equals, I'm going to write the, well, square root of 3 times s over 2. Square root of 4 is 2. Another way to write that, I'm going to put it as s times the square root of 3 over 2. So, what do we have here? Well, if I know the hypotenuse, which is just s, then all I have to do is multiply by square root of 3 over 2, whatever that is. And I have, so the hypotenuse times square root of 3 over 2, that's going to be that longer of the two legs. I'll literally call it the long leg. But what if I start with the small side? Be careful on this one. If I start with that small side, the small leg, see the small leg in our diagram up there is s over 2. So if I start with s over 2, which is what that is, all I got to multiply by is the square root of 3. So if I take the small leg, if I'm given that, I just multiply it by the square root of 3. 3. There we go. So let's clean this up a little bit and so we can start committing it to memory. So here's what we've hopefully picked up from this. And this is the part you're going to memorize. So even if you were like a little lost on the algebra I just did, this part you can do. Let's say I start with, I always like to try to find, if I can, the small side. Let's say I start with the small side. And let's say I'm going to call that Q. Just pick a letter. Doesn't matter what letter it is. So what do I know about the smallest side and the hypotenuse? This is the easy one. All I got to do is double it. So the hypotenuse would be 2 times Q. What do I know about the small side and the larger leg? Small leg and the larger leg. That I multiply, and it stands to reason we're going to multiply here because we're going to be larger, although you can multiply by like 0.2 and make it small. But in this case, we're going to multiply by the square root of 3. So that's going to be Q times the square root of 3. So going from the small leg to the larger leg, I'm going to multiply by the square root of 3. From the small leg to the hypotenuse, I'm going to double it. But what if I start with the hypotenuse? What if instead, we'll pick a different letter, we'll go M. Let's say they give me that. Well, how do I get from here to for me, I always key on the small leg. How do I get from here to the smaller of the two legs? Well, if this is m, this is going to be half of m. Now, I just look at it like this. How do I go from the small leg to the larger leg? Multiply by the square root of 3, right? So this is going to be m over 2 times the square root of 3. And you can write that in any number of ways, by the way. So these would all, this little expression is all the same. I could write m times the square root of 3 over 2, like that. Kind of put the m out front there. That's the same thing. I could write m square root of 3 all over 2. That's the same thing. I could even write, I guess, m over 2 times the square root of 3. That would be the same. All of those mean the same thing. And really, this looks like what we did. We took m over 2 and we multiplied by the square root of 3. But really, any of these three ways say the exact same thing. You want to practice this. And you want to at least get from here to here. Because if you can get two of them, you could always go back and use Pythagorean theorem to get the third. But you need at least two to do that. So if they give you one side, you should be able to get from that side to the short side. To me, that's the key. And in fact, here, let's go to probably the hardest one you might run across is this. Let's say you have one where they give you, let's call it R, where they give you that long leg. So this is a 30, 60, 90. By the way, it's the only time this works is if 30, 60, 90. Let's say they give you that. All right, so what can we do? How do I get from there to the small side? I always like to go to the small side. The factor, the number involved, is the square root of 3. So going from here to here, larger side to the smaller, I'm going to divide by the square root of 3. So this is actually R over the square root of 3. What do I do to get from the small side, or the small leg, to the hypotenuse, though? I just double it. So I'm going to write 2 times R over square root of 3, which is just 2R over the square root of 3. Or you could write it as, well, there's a bunch of different ways as we just looked at, but that would work. So the trickiest, I think, is starting with the longer leg. Because then you got to remember, square root of 3 is obviously the trickier one to remember. I don't know why, but it seems to be. But you're going to divide by the square root of 3, gets to there, and then we double it to get to the hypotenuse. So let's do it with numbers once. So you're going to want to pause the video and work this out on your own. I'm going to go nuts, and I'm going to draw the 30, 60, 90 a different way. You're going to be okay. It's really going to be all right. It's really not that much different. All right, let's say I give you, make this a simple one. Sort of simple, right? We'll make this 7. Give me the other two sides. Now, remember, don't give me a decimal. Give me a quote, an exact answer. All right. Pause the video, and then come back when you think you got it. I'm going to forge on. So if I have the smallest side, the first thing I remember is the hypotenuse is going to be double that. So that's going to make this 14. And to go from the small side to the longer of the legs, it's going to be times the square root of 3. That's the factor I remembered. So it's going to be 7 times the square root of 3. And I'm done. Let's try it with another one. Let's try... Freaky. I know. You're going to be okay. It's all right. Let's try this. Oh, what the heck. Let's just do it. Let's say this is 11. Pause the video. See if you can figure out what the other two sides are. Here's your answer. So going from what I gave you isn't the hypotenuse. It's the longer of the two legs. So I have to remember to divide by the square root of 3 to get to the small one. And then double this, 2 times 11 over, so 2 times 11 over the square root of 3. Remember, that's just 2 over 1. You multiply, that's going to be 22 over the square root of 3. You're going to need to practice this until you got it. Again and again and again. It will help a little bit in this class. It'll help a lot in mathematics classes, And it's just in general a good thing to know to get you through some problems quickly. Because tests love to give 30, 60, 90 because they feel like they're giving you an advantage. You don't have to use a calculator or whatever. It should come out easy because, quote, easy because it's something everybody, quote, everybody knows. Well, I'm here to help make sure that you know. All right, practice this, and then we'll move on from there.